Okay, going through question number 12. A particle moves along the x-axis with the velocity v as shown in the figure. It's just FYI, this is in essence, a derivative already, right? The particle is the farthest to the right when t is equal to 4. Is that true? When t is equal to 4, the particle is farthest to the right. So given the whole graph, let me ask you a question. If this is my velocity, okay? And at x is equal to 1, I'm heading at a positive speed. At 2, I've stopped my velocity. At 3, it's a positive. 4, it's a positive velocity. 5, it's a positive velocity. 6, it's at 0. But 6.5, that's a negative velocity. So in essence, I'm going, talk about this in cars, right? I'm walking 1 mile per hour forward. I'm walking at 0 miles per hour forward. I'm walking at 1.5 miles. I'm walking at 2 miles per hour. I'm walking at 1.5. I'm walking at 0. And all of a sudden, I decide to walk in a negative velocity, to go backwards. So what point is the farthest? I would claim the farthest point is actually at 6. Because I've been going forward. I kept going forward after 4. And I didn't start going backwards till after 6. So I'll claim this is false. Answer is false. They drew a little sign chart here to say I went in a positive velocity going forward. At the points of 2 and 6, the velocity was 0. That means you stop moving. It's like you stopped your car. It's like you stopped the car. And then after 6, I decided to hit the reverse, started backing up. So I started moving left. So number 6 is asking about the horizontal asymptote. Now, if you remember anything in pre-calc, horizontal asymptotes happen looking at these guys here. And if I wrote this differently, 10 plus 5x squared over 5 minus, x squared, if I wrote it this way, we know if the exponents are exactly the same, we have a horizontal asymptote at positive 5 over negative 1. You guys remember that ish? And the one reason why is if I plug in, let's say 100. Well, what does 10 matter? If I plug in 100, that'd be 50,000. If I plug in 100, this would be 10,000. So 50,000 divided by negative 10,000 is going to be the same thing as 5 over negative 1, which is negative 5. Okay, that's our rule. If I plug in negative, sure, put negative there. Which squares would be positive? Same answer. But because this is e to the x, that's where the trick is. Now, and that's where we're crapped out. The statement says this only happens here, and that's not true. Because if I wrote 10 plus 5 e to the negative, let's say negative 10, over 5 minus e to the negative 10, we write this as 10 plus 5 over e to the 10 over 5 minus 1 over e to the 10. So to illustrate this, what happens to this fraction as e gets shot off to negative infinity?
It goes to 0.
Goes to 0. That's 2. So the idea is, as e gets bigger here, if it goes to 10, to 100, to 1,000, hey, these guys are exactly the same speed, so it's just 5 over negative 1, which is their answer here. But if I plugged in negative infinity, that becomes a crappy fraction. And crappy fractions go to 0 as we go to infinity. So it'll be 1 over 1,000, 1 over 1,000,000, 1 over 1,000,000,000. That leaves us only 10 and 5 left over. So it's the same question if I ask you this. What is the limit as x goes to negative infinity of e to the x? Well, the graph looks like that. E to the x gets bigger as we go to the right, but it goes to 0 as we go to the left. Because if I stick a negative value there, it becomes the limit as x goes to infinity of e to the negative x, which really gives me a fraction, which leads me to 0. Okay, number 19. The number of people waiting to ride a roller coaster is modeled by the function n to the t, which is given here. That's our graph. And this is the number of people, right? I do this as people. T measured in hours after the ride opens at 10 a.m. So number of hours, this is 10 a.m. The average rate of change of n between 11 and 1. It's 11, 12, 1 a.m. is greater than the instantaneous rate of change at noon. So here's noon here. Is it true that the average rate of change is greater than the instantaneous rate of change? Does it look like it visually?
No.
So the average rate of change is our slope versus our instantaneous rate, which is the slope at that one point. So we saw that the average rate, which is, let's call the color in blue, is not greater than the instantaneous, which is covered in, I'm guessing that's red. Okay. So these types of problems are written somewhat confusing on purpose. But the question is, can you split up the values? So one of the hints is to remember, well, let's read it. First, they gave me a given. That is given. I know it from 1 to 3. But you look automatically here, that's not 1 to 3. Fine. We'll have to deal with that. So instead, I'm going to break up the right side. Because if this is my only given info, I need to get the right side to look like the left. So the right side becomes the integral of 2 to 4 of f of x minus 1 plus the integral from 2 to 4 of 2x dx. Right? Now, let's go ahead and see what the left integral looks like. If I plug in 4, that turns out to be a 3. This turns out to be a 1, which is the same value here. So it turns out the first integral is just -6. Well, the second integral, we know how to find the integral of that. That's just taking the integral of 2x, which is 2. Oops. That's 2x squared over 2. We're going to plug in between 2 and 4. And that's going to be 2, let's try it separately, 16 over 2 minus 4 over 2, which is 2 times, oh, there's 2 cancel out, I'm sorry. It's just done that in the beginning. But it's going to be 12 over 2, which is just 12. So 12 minus 6 is 6, which is what I'm getting here. That looks like a true statement to me. It is true. Okay, if f of x, number 8, if f of x is equal to x cubed plus x, and g of x is the inverse of that, what is the derivative of the inverse at 2? Do you guys remember what the rule for the derivative of inverse is?
X equal Y.
X equals to y.
Don't you switch them?
Yeah, that's right, we do kind of switch them. We wrote this is equal to 1 over like capital of, oh wait, it's like a regular f of y or something like that, right? So, or like it's the other one. So if this is 2, we want to figure out what the other value is going to be. Okay, so let's see. So do you guys remember we take the derivative of this? So it's f prime of x is equal to x cubed, 3x squared plus 1. and then we plug in not 2. Was it 2? Let's draw the graph real quick. Let's draw the graph. If this is my graph, the inverse graph looks like this. If I point, let's call this a comma b, we said that this derivative looks just like b comma a's derivative, except the reciprocal. So if I'm plugging a here, that's really the y value there. So what's the x value that we're going to plug in? Well, when does this graph, oh, I'm sorry, wait, no. So what would the x value be for this value if I solve for that?
2.
2 is equal to x squared cubed plus x. Is this a non-calculator? Would it be, would this be 13? Is this a possibility? So would this equal to 1 over 13? That has to be 13. Let's solve for 13. 3x squared plus 1 is equal to 13 minus 1 minus 1. 3x squared equals to 12 divided by 3. Divide by 3. X squared is equal to 4. X is equal to plus and minus 4. No, plus and minus, I'm sorry, 2. Is 2 an answer? Or is negative 2 an answer? Here. If I plug in negative 2, that's negative 8 minus 2 is not 2. If I plug in positive 2, 8 plus 2 is not 2. Answer is false. That's what I'm getting. Okay, so this is FRQ number 3 for us, and we're doing E. So is it possible for the curve to have a vertical tangent when, on the y-axis, which is here, where x is equal to 0? Now, our idea of vertical tangent is going up and down, and we know it's a vertical tangent because pretty much we divide by 0. If you think about this slope is infinity, means it is an infinite rise over run. You rise a lot over a 0 change. So we're looking for the 0 being at 0. So when I'm looking at this, I'm thinking, okay, since the derivative was given already, when will this derivative equal to 0? Y squared minus 1 is equal to 0. Now, when does that happen? Y squared is equal to 1.
So minus 1.
And then, so y is equal to plus and minus 1. Is it possible for this curve to have a vertical tangent at a point where it crosses the y-axis? And if the only time it has a vertical tangent is when y is equal to plus minus 1, I would say no, because the vertical tangent is when I'm dividing by 0. Does that make sense? The second part here is to when is the graph actually going to be y is equal to 1? So we came up with the, I think, equation of the graph, which is 2y cubed minus 6y plus 3x squared minus 18x equals to 12. So check 1, plug in 1, and see what the x value has to be. In this case, this will become 2 minus 6, because y is 1, plus 3x squared minus 18x equals to 12. If you go ahead and solve this, it's going to be 3x squared minus 18x equal to 16. Okay. And if I put x as 0, see, remember, we want x to be 0. If I put 0 here, does the answer become 16? No, doesn't look like it. If I try the other version, if I try negative 1, this becomes a negative 2 plus 6, because those are negative, plus 3x squared minus 16x equals to 12. We move these over, it becomes 8. 3x squared minus 16x. Now, remember, I only care that x is 0. At x is 0, does the graph look like 8?
No.
Nope. So they are not equal to 0. So of the two places that this was going to happen, y is equal to 1, none of them was x equals to 0.